explain what the slope b and the intercept a mean in the equation y equals ax plus b of a straight line. Explain what the slope b and the intercept a mean in the equation y equals a plus bx of a straight line.
Well, y-intercept is y equals ax plus b. The a or the m is the slope, and the b is the intercept. So, m and a would be x, would be the x-axis. It would control the x-axis. So, what number you have would determine how many spaces left or right. You can also have a negative slope, so you can go to the left on the graph. And so the intercept, which is b, is your y-axis. So you can have a positive again or a negative slope. Sorry, not a slope, but an intercept, and you can go either up or down.
Regression line. It is a straight line that describes how a response variable y changes and explanatory variable x changes. So we can see the example, like what we've predicted so far for a regression line, and we can predict that this here is like y-axis and here's the x-axis. So we go vertical and then horizontal.
Explain the danger of making a prediction outside the range of available data. Well, the danger is extrapolating. Extrapolating is making a prediction that goes beyond the set of data given. We have an example for this. Let's say you're trying to predict the grade you will get on a test based on the number of hours you've studied. So I've already set up an equation, and that is 7x, y equals 7x plus 50. I've already drawn the best fit of line and did scatter plots. Scatter plots.
So basically what you're trying to say is that the number of hours you study is mostly 7 hours. Is that correct?
Yes. I've studied 7 hours and got a 50 on a test.
And you predicted that you might get a little bit higher on that.
If I've studied more.
But eventually you just didn't predict it that well.
That is true. That is correct. So, if I were to graph 9 hours and I've got a higher grade, you can't get a higher grade than a 100. So that wouldn't be valid.